Hello everyone, so welcome to our review on graphing exponential functions. So we will be graphing, let's say, f of x equals 2 times 3 to the x minus 1, let's say plus 1. Okay, but before we graph that, let us just try to recall the basic graph of a exponential function. Okay, we know that the graph usually has the horizontal asymptote at y equals 0, or the x-axis, okay, or x-axis, and usually it has the y-intercept at 0, 1, okay. So this will be our graph there. This will be at 0, 1. So usually that's the graph of our parent function. So let's try graphing the function f of x equals 2 times 3 to the x minus 1 plus 1. So first and foremost here, I want to graph the asymptote, which is at positive 1, okay? So we have, if that is your x-axis, this is your y-axis. We have the asymptote at 1. Let's say this is your asymptote. Okay, that's y equals 1. Okay, so next here is we find the, okay, so since we know that the a value here is positive, so the graph is going to be contained above y equals 1. So therefore, we don't have x-intercept. Okay, so what we can have is y-intercept. To find the y-intercept, we let x be equal to 0. So we have y equals 2 times 3 to the 0 minus 1 plus 1. And this is going to be 2 times 3 to the negative 1 plus 1. So we have 2 times 1/3 plus 1. And that's 2/3 plus 1. And that's equal to 5/3. Okay, so that's our y-intercept. So since we're just sketching it, let's say this is your y-intercept, and that is 5/3. Okay, that is 0, 5/3. All right, so next thing here is we will find where will this 0.01 go. Okay, so what is the new transformation of 0.01? So we know that the x value or the x coordinate 0 will be transformed because of this, right? And there's a horizontal shift 1 unit to the right. So therefore, we will be adding 1 to your x values. So instead of 0, 1, it goes to positive 1 because that's 0 plus 1. And for your y value here, this 1 right here, we will multiply that by 2 and add 1. Okay, so 1 times 2 is 2 plus 1 equals 3. So 0, 1 goes to 1, 3. Say 1, let's say this is your 3. So this is your 1, 3. Okay. So here's now the graph. The graph is, okay. I'm sorry for that. there. Okay, so we know that the domain here will be all real numbers. So set of all x such that x is an element of real number. And for the range, we know that the graph is above y equals 1. So we have the range set of all y's such that y is an element of real number such that y is greater than 1. Okay. As for the end behaviors, okay, end behaviors. So as x approaches positive infinity, as it goes infinity, the behavior of the graph is increasing. So f of x approaches infinity also. And as x approaches negative infinity, the graph is approaching, or f of x is approaching positive 1. Okay, so what else do we need to do to discuss here? And for the interval, okay, no, for the interval, we only have 1. And when you identify the interval, you have to read the graph from left to right. And as you can see, from left to right, it's increasing. So the interval is increasing from negative infinity to positive infinity, and that's increasing. Okay? All right.